Hi, in this video I'm going to build upon a previous tutorial entitled SDL 2.0 on Android using the NDK. There's a link to this video in the description below. In the comments to that video, IDFan Engine Coder asks a question regarding how you would build a shared library using the NDK that could then be used by all members of a team. So we're going to step through this now. It's actually relatively easy to do. In keeping with all my previous tutorials, I'm going to build a shared library that will use OpenGL ES 2.0 to clear the screen to a specific color. That pre-built library will then be linked into the Android project, and there will be no explicit OpenGL functionality in the Android project itself. The OpenGL functionality will be in the pre-built shared library. So to start building the shared library, you don't need Eclipse. You can do it all from the command line. So I'm going to make a directory and I'm going to give it the name of my project, which I'm going to call OpenGL Engine. Inside here, I'm going to make another directory called Ginny. This should be familiar to you based on the SDL 2.0 Android project. And inside Ginny is where I'm going to place my Android makefile for my shared library. So rather than you watching me typing, I'll just paste in some code here. So this makefile is pretty standard. It sets the local path to the current directory, set the module name, and then set where the code is. So I'm going to place my engine code in the parent directory in a folder called engine. It's going to include files from the include subdirectory of that engine, and the source files will be again in the up directory, in a directory called engine, and then in a subdirectory called source or src. And then I'm going to tell NDK build that in this I want to build a shared library. So if we run NDK build on this, it immediately fails because it can't find engine.cpp. Well, it's fine, we don't have it. So I'm going to go to my parent directory. So I'm in my OpenGL engine, and I'm going to make a directory called engine. And in here I'm going to make include, make source. I already have files that I'm going to use. I'll quickly show you them in a minute. So if we look at this, include engine, so it has one function called clear screen that takes an RGBA value. The A value is preset to be 1 unless specified otherwise. And then if we look at the source, we include the OpenGL functionality we need, the OpenGL ES2. And then we set the clear color and clear the color bit. Very basic. So now if we go back here and do an NDK build again. Okay, so it's found engine.cpp, but it doesn't know where to find GLES header files. So if you look in your NDK, the NDK download, you'll have a platform, and then you'll have multiple platforms, multiple architectures, and then in here is where you'll find the libs and the include files. So let's find the include file it's looking for, GLES2, GL2. So this is the one I can't find. The reason I can't find it is it knows about the NDK knows where it's been run from, because it's run from right here, and it can go into platforms, but it has no idea which one of these it is supposed to use. Because if we look, there's GL functionality for each of them. So we need to tell NDK Built, when building this shared library, which Android platform you want it to use. So where am I? So back in Genie, if you go vi application.make, and in here set the app platform to whichever you want to target. I'm going to use the most up-to-date, Android 19. You don't have to use that, you can use whichever one you want. So let's see, undefined reference to GL clear. Okay, this also makes sense because we're including the header files, but OpenGL is a library which we're not including. So back into Android Make, and we want to add the local LD libs to, actually I want version 2, don't I? Okay, so there you go, that's your shared library being built. If we look in, you'll see that now there's also a libs and an objects directory. We can ignore objects because that's used by the compiler. We're interested in the libs. So there we have an ARM ABI, and you have your lib OpenGL engine.so. So look, that's your shared library being built. It's that easy. But there's one thing I'd like to address before moving on and showing you how to add it to your Android project. And that's, we're only building for a single platform here, because that's what the NDK is currently targeting. But what if you want to target something else? Do you want to come back here and set it up and rebuild the project? Really you don't. You want to have a shared library available for every possible architecture that you might target. And you can get the NDK to do that for you pretty easy. So go back into your JNI directory and look at your application.make, and into that you use this app ABI variable, and you can set it to a space delimited string for every architecture you want to target. So there I can set, as you can see, for ARMY ABI, V7A, and x86. And if I rebuild, here you can see that it incrementally or sequentially processes each of the architectures, compiles the engine code, creates a shared library and installs that shared library to the libs directory, and each of the shared libraries is put into put as a file in a directory that's named after the architecture it targets. So again, if we look in the libs directory now, you can see that we have our 3 architectures, or our 3 folders that map to an architecture. And there you go. 3 shared libraries, identical functionality, identical name, but each targeting a specific architecture. So this will be useful for us in a moment when we're creating our Android project. Now let's move on to part 2 of the tutorial, and this is where we will set up our Android project to use our pre-built shared library. The first thing I'm going to do is copy the Android project from my STL folder. And let's navigate into that. I'm going to do some quick typing here. If you're not sure what I'm doing, please watch my previous video in the description below. In that video I explain how to set up STL 2.0 for Android, and that's pretty much what I'm doing here. For the main of this project, I'm going to use a file I already have. What this file does is it sets up, well, first of all, it's based on my previous tutorial source, so it does more than strictly necessary, but it sets up STL to run using OpenGL ES2, creates the window, creates the OpenGL context, adds an event watch, and then on the run it pulls for events, it STL logs information based on every event that's received, and it does a render every frame as well, which is this line here. Shutdown clears up, and then the render, it calls clear screen. So clear screen doesn't belong to OpenGL ES2, it doesn't belong to STL0, it's not declared in this file. This clear screen is the method that we added to our shared library, which in a moment we're going to add to this project. So the event filter just prints out some specific event information, and the main, it initializes and it runs and shuts down. So if we build that, STL is going to build. It takes a moment or two, so I'll pause the video. Okay, so STL 2.0 has built, but when building main, we get a fatal error, engine.h can't be found. Well, that's because we haven't added it to our project. Rather than copying it from our shared library, I'm going to use the tried and trusted method of creating links to the real source, so that if it updates I don't have to remember to copy it here, etc. And I'm also going to add a link to the libraries, because we need them. So back inside your Android.make file, I'm going to add another module. So this module, again, clears the vars. I've set the module name to be OpenGL Shared Library. This module name is necessary so that we can reference this module from other modules. The local source files, we don't have local source files for a shared library, where it's a shared library. But thankfully NDK doesn't care. You can give it a shared library for the source files. An interesting and useful feature is this target arch ABI. At parse time, when NDK reads this file, it hot swaps this value with the current architecture being targeted. That's handy, because if we look in our Android project JNI source, we have this libs directory, and our shared library, our pre-built shared library, is in a subdirectory which is named after the current architecture. So here, if we're building for x86, NDK build will swap this to be x86. So our module is going to look for the shared library in libs x86 lib OpenGL engine, and on disk it's in libs x86 lib OpenGL engine, and the same applies to the current architectures. So what this ultimately means is that so long as you build your shared library to so that it targets all the required architectures that you may need, when you're building your Android project and you change the target, you don't have to modify your makefile. It will automatically pick up the correct shared library. If you target an architecture that you haven't built a shared library for, you'll get a cannot find error when it tries to read this. The local export C includes. We have this set to local include because that's where our header file is. And what this does is that any module which includes this module, it will automatically get this value as part of its local C includes. If we look at it in the context of programming, if you include a header file A, and it in turn includes header file B, C, D, E, your program includes B, C, D, E by including A. And this is the same thing. By including this module in a secondary module, which will be this one, the secondary module automatically gets this value as part of its C includes. So we actually have that value replicated, so we'll be able to remove this, and when we add the module, it will automatically get it. If I'm not explaining that 100% correctly, I would recommend that you go and look in your NDK download inside of docs for this android.mk.html file, and you will see that it says that local export C includes is the same as local export C flags, but for C include paths. This can be useful if bar.c wants to include headers that are provided by module foo. So I'm not going to bore you with my monotonous tone by reading what local export C flags is. By all means pause the video, or preferably actually go and read this file. There's tons of very useful information in there. You may not need all of it, but it will make you more familiar with the Android make process and all the different values that you can use. So we've set up, well, the last line is, as always, to tell NDK build what you want this module to be used for. So, for example, here we're saying that this module is used to build a shared library, and it's used to build libmain.so. So we want to tell NDK build that this module is used to configure a pre-built shared library, so it knows what to do with it. So now we need to use our pre-built shared library in our project, because if we just build that, we're going to get back to the same error where it can't find engine.h because we've removed it. But if we add the module name here as part of the shared library, firstly, it will find engine.h because it's part of the local export C includes, but also it will be able to find the shared library and link against it and compile correctly. And there you have it. Our main shared library has compiled, and it knows that it's dependent on the lib opengl engine.so. If we go back up to our Android projects and check out what libs it wants to include, excellent, it has the three libraries we need, our libmain and the libstl and libopengl engine.so. So now I'm going to open up Eclipse and do file, import, existing code, and import our project. And then we can quickly review and see that yes, it has the three libs inside our JNI. It has SDL, but it also has our source. So it's clearing the screen to a random color. I think I have an emulator running somewhere here. So there's my Android emulator. So if I run this, run the project and target that virtual device, and there you go. The screen is being updated with a random color. So just to set our mind at ease and be confident that it is this call here which is updating the screen, let's go back into our shared library, into engine, source, and let's look at the source. And I'm going to ignore whatever is set by the parameters, and I'm going to set the color to a bright and nasty pink. So I've rebuilt the shared library, rebuild the main library. So now let's run the project again, and hopefully it will be clearing the screen to a bright pink. So you can see down here that it's uploaded the APK to the emulator, it's installing the APK. There you go. If when you run your application the second time it continues to display in random colors, try rebuilding your main shared library or restarting Eclipse. It can be a bit finicky sometimes, but that goes to show that the update for the clear screen is actually coming from the shared library. If you have any questions, please feel free to comment on the video. I'll get back to you as soon as I can. Thanks.